Objective number 11 says know how to use the ideal gas law and stoichiometry to convert between volume and mass amounts of products and reactants. So the big thing with stoichiometry is you're going to have to use a balanced equation if you're starting with one substance, volume or mass of one substance, even moles, and you're being asked to tell volume, mass, or moles of a different substance. The only way you can do that is comparing the molar amounts with your balanced equation. So if you have solid potassium chlorate, the first thing you have to figure out is what's the equation for potassium chlorate. Anybody remember what chlorate is? Yeah, ClO3, and its charge is just -1. So with potassium, that would be KClO3. And it decomposes. Is it 2? Decomposes into potassium chloride, so just KCl, and oxygen gas. So you have to balance this one. With the oxygen, I'm going to need 6 oxygen to balance it, and a 2 here. So a 2 here. So once you have the balanced equation, then you can look at what you actually have. It says how many grams of potassium chlorate do you need? So I'm being asked for grams of potassium chlorate. Now that said this is a solid, so I usually don't care if you pay too much attention to the state, but when you're using the gas laws, it's important that you realize that these two things are both solids. So you can't use the gas laws with solids. Let's see if I can get that in the right place. The O2 is a gas, so we can use the gas laws with the O2. But I'm being asked for grams of KClO3. If I want to produce 100 liters of oxygen gas, at a temperature of 450 K, so it's already converted for me, so don't add 273 to it, and a pressure of 2.5 atmospheres. So if I look at what I've been given, this is volume, this is temperature, and this is pressure. But what I need to do anything with this equation is I need moles. Yeah, so I can use the gas law. So first step, I need moles of oxygen. So you can use PV equals nRT, and we'll solve for N. So P is 2.5 atmospheres. The V is the 100 liters. N's what I want. R value, 0.0821 because it's atmospheres. And then T, it's already in Kelvin, so don't goof that up. So if you solve for that correctly, you should come up with I'm getting 6.77 moles, and that's of O2. So then I can use that. Now I can use the balanced equation, or my molar ratio, to find moles of KClO3. So 6.77 moles of O2 Oops. So what's the molar ratio I should be using here? Yeah, it should be 2 moles of KCl O3 for every 3 moles of O2. So what you come up with, like 4.5 or so? 4.51 moles of the KCl. Oh, I didn't want that. I can't get to my undo button. And then finally, once you know how many moles of KClO3 you have, so the molar mass is going to be 1 potassium weighs, what, 40 or so? 39.1 plus 1 chlorine is 35.45 plus 3 oxygen. So the molar mass for potassium chloride is 122.55. So I take my 4.51 moles of the KClO3. This would be kind of hefty. So 553 grams.